guys, this is the video for section 10.2, volume of prisms and cylinders. So section 10.2, volumes of prisms and cylinders. We are going to find the formula. So up to now we have just talked about prisms and cylinders. We found the surface area for prisms and cylinders. But now we're going to actually look at the volume. So the difference between surface area and volume is something very important for you to understand. The surface area is how much area the figure takes up if you were to lay it flat. So those figures that you originally cut out and you left them flat, you found the area of each side. That is the surface area. The volume is how much space it takes up. So I want you to think about having one little cube, like this one right here. The volume would be how many of those cubes does it take to fill up whatever kind of prism you are referring to. So if your rectangular prism is 3 by 12 by 8, how many of those little cubes does it take to fill it up? Well, you would take 3 times 12 times 8, and that would give you the volume. And because it's centimeters times centimeters times centimeters, our final answer will be centimeters cubed, or whatever our units are, cubed. So the volume, this is conjecture 86A, of a rectangular prism is going to be the area of the base times its height. And these pictures up here, A, B, and C, they're rectangular. So the area of the base, in this case, would be 3 times the 12. So that's our big B, and then our H is the height. So remember that big B is the area of the base. And that is going to be your formula for all of your rectangular prisms. So if it's a cylinder, because our cylinder, the circle, the base is a circle, instead of writing big B, which you can still just write big B, or you can write pi r squared times h. So that is conjecture 86B. Make sure you put me on pause and get those into your notes. Now we talked a little bit about oblique rectangular prisms. I told you we weren't going to talk about them a whole lot, but if it is oblique, it's just going to be the same formula. The volume of an oblique prism or cylinder is the same as the volume of a right prism or cylinder that has the same base and the same height. It's just like taking a rectangle and tilting it to make a parallelogram. It still has the same area formula. So if we stack a bunch of parallelograms on top of one another, that makes an oblique prism. But the area is the same of the base, so the volume is the same for the prism. So we are going to have one conjecture, conjecture 86, the volume of a prism or a cylinder is the area of the base, so big B, multiplied by the height. So volume equals big B times H, where big B is the area of the base, and that's going to be a polygon, times the height. Remember, the height is the length of the altitude, and the altitude is perpendicular to the base. So look for that perpendicular altitude, which will be the height. Okay, so put me on and work this example. And let's see if you get it right. Okay, so you've had time to work it. You can check your answer. The area of the base was a trapezoid with a height of 5 and the two bases were 4 and 8. So we plug big B into the formula. The whole height of the figure was 10. So our volume is 300 centimeters cubed. Let's go back and look at that. Here is our trapezoid, which is our base. This number down here is 8. So big B is 1/2 the height of our trapezoid, base 1 plus base 2. This is the height of the prism. So 10 is the height of the prism. So our formula, volume equals big B times H, will be 1/2 of 5, 8 plus 4. So that's the 30 times the height of the whole prism, which is 10, to get the 300 centimeters cubed. Okay, try this one. Put me on pause and work it. Notice it's oblique, but the height is given. Okay, now check your solution. The area of the base is 36 pi, using the formula pi r squared. So the volume is 36 pi times 7 for 252 pi. Let's go back and look at it. The radius of our circle is 6. So big B is 6 squared times pi, or 36 pi. So our volume, which is big B times H, will be 36 pi times the height of the whole prism, which is given to be 7. That's that perpendicular length. So that is how we get our answer of 252 pi. Oh, sorry, that was inches cubed. Inches cubed. Okay, so for homework, I want you to do 4 problems. Here are the first 3. All measurements are in centimeters, so we're going to have centimeters cubed. And it says round your answers to the nearest hundredth. We're not going to have to worry about that on these 3 problems. So this base is a triangle, then we have a trapezoid, then we have a regular hexagonal prism. So if you'll remember, big B will be 1/2 base times height. Here, big B will be 1/2 the height, base 1 plus base 2. And in this last one, big B is 1/2 apothem times perimeter. You may want to go back and look at that video from that section where we did regular hexagons, because I reviewed the 30, 60, 90 in that video. That was section 8.4. So if you need to go back and look at video 8.4, you might want to do that. And then the 4th problem I want you to do is this one, a right rectangular prism. I'll see you in class.